Welcome, everyone. Thank you for tuning in, and I will turn this over to our Qualitest team for their presentation.
Thank you so much, Susie. Nice to be here. My name is Aviram Shotten, Chief Solution Engineering Officer in Qualitest. I have with me Michael.
Hi, everyone. My name is Mike Giacometti. I am a solution architect here at Qualitest.
We came to speak to you about our opinion about shifting testing. This presentation that you will see is built to show evidence why we think that we need to change, and then how we think we should change and what the right steps to do that, with some real tangible evidence on why change is needed and why change is and how change can be successful. So without further ado, let's start with the presentation. So we went out and checked what is it that people base their opinions regarding testing on. We checked why testing is being assessed and in what ways, and what is meaningful for decision makers, for stakeholders, to assess the value, the tangible value that comes out of testing. And not surprisingly enough, or not surprisingly at all, you will see that defects, basically tangible evidence that testing is identifying defects, is what makes testing valuable for decision makers. 37% said production incidents, 39% said mean time to repair, basically on the back of an incident, the back of a defect. How long does it take to fix the application? And number of defects that identified throughout the testing services. The next slide is even slightly more grimmer. The next slide will show us a little bit how much progress have we made in terms of efficiency and in terms of improving the way we work. So we looked at 2015. From the overall invested in development, the 100% of effort invested in development, 60% is in the technical tasks of either development and testing. And that is for 2015. You can see that we invested 26% in development and unit testing, defect removal, deployment, quality engineering management or test management, and this all summed to 60%. Since 2015, I think there was a perceived quantum leap, right? We got so much better in adopting digital practices, Agile and DevOps. And in 2020, we're still at 60%. The needle hasn't moved. We can all talk about continuous testing and we can talk about how sophisticated we've become. But in the end of the day, 60% 5 years ago, 60% today. For me, this is a wake-up call. This was a wake-up call that we acknowledged maybe 2 years ago. So what is it like from our point of view, testing the normal way? What is it that we do? I know it's rather simplified, but this is how we do things. We have the test repository, which comprised of all sorts of tests, also all sorts of levels of testing, different practices of execution and definition, automated and manual, all executed on the application on the test. In reality, what happened on our seek and our quest for quality, we execute the test thousands of times. We invest a lot of effort in maintenance. Most of the tests are, or the massive part of the tests are ending in a success. Okay, tests are passing. Analysis of what's really happening is almost impossible because of the high throughput of testing. Because of the high ratio of success testing, there's a false sense that everything is okay. 95% of our test cases were passed. The application is really good. I'm not sure this is a good enough metric. And if you test a lot and you find very little, you become indifferent. You increase your chances of missing out on a defect. And this is, I promised you in the beginning of the presentation that we will be opinionated. This is why we say we need to change the way we test, okay? We should not be talking about functional coverage anymore. We should be focusing on defect detection and risk coverage. In the end, today, applications are so sophisticated, so big, and so critical to the business that if we will just focus on functional coverage and not on covering the risk that those applications represent, we will do a disservice to the people who pay our salaries. So we build a simple equation, or at least as simple as we could. On the equation, on the one side of the equation is intelligent testing, implementing the right kind of automation pyramid from unit testing all the way up to UI end-to-end levels. In the middle, we will find the integration testing and API. And we will do, of course, we will look to optimize the way we do our end-to-end testing. For example, practices of risk-based testing or AI, as we are going to discuss today. On the other side, the infrastructure automation. I like to say that infrastructure automation is hidden in plain sight. Why is that? Because if we don't have the right level of sophistication in infrastructure automation, we just accept it, and all of a sudden the velocity of delivery goes down. So in order for us to have the right level of infrastructure automation, we will need to have environments automation and test data generation. Today, however, yes, thank you. In the end of the day, those equals velocity. Today, we would like to focus just on the end-to-end element, the test optimization. Let's park for now automation pyramid. Let's park for now infrastructure automation, and let's focus just on test optimization, how we can make our testing much leaner, much more sustainable. I think that this is time for me to hand over to Michael.
Thanks, Aviram. So if you've done automation before, which I think most of us have, you realize that everything comes at a cost versus scale issue. You've seen it done before. It doesn't matter if you're using open source tools or commercial off-the-shelf tools. There are things that need to be managed. And so if you look at the costs, where do the costs of automation come from? Traditionally, they come from areas such as maintaining and creating the skill sets, working with the test cases, finding the skilled resources. If you're using off-the-shelf software, what is maintaining the cost of those licenses? And then, as we've pointed out, infrastructure has a cost. Do I need to run on a cloud? Do I need to run on-prem? And what happens is that regardless of if you choose open source or off the shelf, you're basically incurring costs in each of these four areas. But what you're doing is you're doing it in such a way where you're just sliding the levers. So if you're using open source, there's more of a maintenance cost. If you're using off the shelf, there's obviously more of a license cost and potentially a skilled resource cost, increasing the cost of skilled resources. So now, however, because of DevOps and because of Agile, we're actually scaling it more. The issue you run into here is that you're always looking at increasing suite of tests. You've got technical debt that really didn't go away, and ultimately there's a situational awareness. What's happening? The end result is that the problems that you had when you were small in scale are now just exponentially bigger and larger when you're in a much larger scale. The idea is that the increasing result is that you have a test repository and a test organization that's actually just increasingly unsustainable, more expensive, takes longer to do, and you're fighting harder to keep up the velocity with the same number of resources. So good testing processes and practices can help. However, there are some technical things that you can do. And what we did is we captured the concept. QA has introduced the concept of shift right and shift left. Now, what these terms have meant over the years has changed and evolved. But ultimately, what you want to do with shift left, just a level set, is you want to test closer to requirements by shifting more left. And by shifting right, you want to test closer to production. And what you can see is that while a lot of the improvements around unit testing, automation pyramid, test-driven development, everything else does have a definitive impact on velocity, it does require a lot of effort to either retrofit what you have, or it may not be easy to implement. And the only two exceptions to this are really around test case consolidation and test case prioritization. The concepts behind both, as we'll explore, really are QA 101. If you've done test management or test automation before, you're familiar with the concepts. And consolidation is really the practice of keeping your test repository unique and useful. No duplicate test cases, everything is depreciated and created when it's needed. You've got a always stable set of test cases to use to execute manually or automate it. Prioritization is the concept of focusing the testing to really where the testing needs to take place. And that generally aligns to where your organizational mandate is. The idea that quality is a moving target, it means something different to each company in each domain. But the problem with both is that it needs a starting point. It needs a set of people who are disciplined. In the case of test case consolidation, especially, is that once a process is set up, I got to keep doing the process. And when you're doing prioritization, it's generally very reliant upon, domain knowledge. You're relying more on gut instinct to prioritize than you are on, data. So there are things like risk-based testing, but when I'm talking about technical complexity versus business risk, it's still a very gut instinct, very, opinionated way to determine things. So what the other instance you have, and most of you are probably in situations like this where testing isn't always done by full-time employers either. It's done by partners. And the partners, as they come on the engagement and come off the engagement, the knowledge can go walking with them. So what do you do? Well, one of the things that has come onto the scene very recently and works very well is to use artificial intelligence. And when we talk about artificial intelligence, most people start thinking about the Terminator or maybe Whopper from War Games or something like that, a robot. Artificial intelligence really isn't that. Simply put, AI can do what you do, just a lot faster and a lot more thoroughly. In QA, we generally approach artificial intelligence in three ways. First one's around AI-powered engineering. This is where we take a look at the entire ecosystem of IT. And we take a look at, where we can accelerate and address certain challenges and how applications are developed and how they're tested. The second one is around testing AI. This one is really a new bleeding edge area because what you're doing is you're actually using AI to test AI. And it's checking the stability, it's checking the accuracy of how AI models work. AI models are really a bunch of algorithms that just need to be trained. How do you test that? That's where AI is being used. And then the third is really around an AI-powered test assessment. And what that does is that looks at different areas, same thing that you would do if you were approaching a testing organization for the first time. It finds areas to address, and then using a bunch of algorithms and the whole AI concept itself really helps draw a roadmap of what needs to be done to improve the quality of testing. And ultimately, when we look at how the process is done, the first thing that you keep in mind when you use an artificial intelligence is that if you can access it, the AI engine can access it. And that's either through REST APIs or maybe different synchronizers or even flat files. If you can get to it, the AI can get to it. And what we're doing here is we're taking a different look at the entire quality engineering process. The first thing that we do is we take a look at the test strategy. We take a look, and by using AI, we can understand what the real issues are versus what are perceived issues. What does gut instinct tell us versus what does the data tell us? Obviously, understand that the data is probably going to be reliable than opinion. Second is going to be telling you what the best way to either solve a problem or address an issue, which way to do that through RCA or root cause analysis. That helps you define the strategy. Second thing you do is that you take a look at the test design. And AI, when combined with best practices from testing, QA best practices, can really address test case creation, maintenance, and it can work on prioritization. something we'll talk about later. The idea here is that the test cases that are created consistently are already optimized. And those test cases that are optimized can be easily automated and then prioritized for execution, dependent upon the release time frame in the window. When it comes to test execution, again, we're relying on prioritization of the execution. What do we execute and how do we handle it? There are two concepts here that are very unique to AI that are quickly identifiable. The first one is, do we need to deprioritize test cases? In other words, I know I'm just as guilty as this when I was learning how to do automation and manage it, is that I consider being able to run 10,000 test cases through Selenium a great success. We had so much automation done. Now, who cares if it found defects? In this case, we want to find defects. We want to be intentional. And so we want to deprioritize what's not necessary and decommission inefficient test cases. And AI helps us do that. The fourth one is really creating efficiency around the SDLC. If you take the original concepts of what QA and quality engineering is supposed to do, it is really to make the software development lifecycle more efficient, to give a quality first mindset. We can do this by removing duplication. We can look at triage and defects. We can take a look at looking at triage and requirements and making sure those linkages work. And ultimately, what happens is that this cycle continues to create a more efficient and optimized way of testing. Now, how does AI help us to shift left and shift right? Well, the first thing it does is that AI really ultimately helps with telling us what really the best design practices are, actually enforcing those design practices. And it does this through deduplication or just removing inefficient test cases. We call this remediation. It used to be a paper process, but now AI has fast-tracked it. AI can tell us what needs to be deprioritized and what needs to be removed and consolidated over time. The other thing that it does too, through test case prioritization, it tells us what to execute and really when to execute it. So that helps us on the left. When we start shifting right, what we want to do, and this kind of breaks into things such as A/B testing and canary testing, anything that you're doing in a production, is really identify what test cases need to be executed in production to validate everything that works, to show the reliability. Indeed, furthermore, what can happen is that if your test suite is good enough, and even if you have AI backing it up, you can actually make activities such as site reliability engineering more effective. So it does provide a couple of benefits to the shift right. One of the other things that it does too is it provides a feedback loop to the left side of the equation before production, during the SDLC, to validate that what we're testing is accurate and efficient. And so let's explore the concepts a little bit more. What I want to do is I want to hand it back to Aviram, who can discuss around consolidation.
So, and this is a simplified way to present what we will be showing you in the next couple of slides. So, first statement we're making is no regrets. What we're going to show you and what we did here is basically taking unnecessary dead meat from testing and classify it in the right way. Now, as a test manager, as anyone who is involved in the testing process, we have our test spec. Regardless to how much of it is automation or manual, this is the perception of the test spec. It's a solid list of test cases that we need to execute from time to time. Some of it is classified as regression, some of it is full suite, but we don't really know what's in it. In reality, this bulk of testing looks a little bit differently. What do I mean by that? The bulk of tests to execute is actually comprised of test cases that are relevant to execute. Some test cases are duplicated. Some test cases are either partially duplicated or suspected duplicated, and the risk that they are covering is actually mitigated at least somewhat in another test case. Their efficiency is lower than other purple test cases. What we are doing is basically representing that defragged pillar in the following way. Whatever green goes to archive because it's a direct duplication. Whatever is yellow, which means it probably have 99% coverage elsewhere, will be deprioritized. And the purple part will be a keeper. Now, just by doing that, a very structure static process, we were able to reduce our test spec by 26%. And I will show you how we did this in the upcoming slide. So yes, we have a technology that does that. That's not a person or a mechanical Turk in the background. And we basically took a big pile of test cases, more than 15,000, and classified them into one of the following types. Cluster 1, type 1, unique test cases. No, we're yet to be in the business of telling you if this is a brilliant test cases that represents a business risk or just a test that is singular and unique. But type 1 are unique tests. It doesn't cover or doesn't resemble other test cases in our pack. Type 2, that's the most straightforward saving we can achieve, right? That cluster contains test cases that are direct duplications because either someone copied and pasted them or someone didn't realize that the test case is existing and basically wrote the same thing in just slightly different way. And without NLP, without AI, we will not be able to tell that this is a duplication because it's not a direct duplication, but it basically does exactly the same thing, and only NLP, natural language processing, can identify two things that are actually the same. Type 3 would be slightly in the gray area. Cluster that have of test cases that have similar functionality. Might have differences, might have issues around efficiency, issues with data-driven, but they're suspect duplicator. Now, later on, we will discuss about what do we do with that, because in the end of the day, we bring this innovation, we bring this new functionality that helps us to be smoother and leaner. But how do we operationalize on this? How do we make sure that this actually get to meet the road? We will discuss this in the upcoming slides. So bottom line, this is what we came up with. We threw these 782 test cases into Qualitest, into our test consolidator module, and we found out that 70% keepers, right? Don't touch them. They are unique. They differentiate from other test cases. We don't touch them. However, 70% is a lot, but I never heard of a manager that doesn't want an improvement of nearly 30% overnight. The remaining 30% had been split between type 2 and type 3. Type 2, 3.2% immediate archive. They are duplicated, even if they are not written in a duplicated manner. They were written differently by a different person. That functionality is covered by that test case and by that test case, and we can get rid of them. The consolidatable, the 26.5% of inefficiency, basically needs to be traced back into type 1 test cases, and then firstly need to be deprioritized, then attached to type 1, basically traced to type 1, and then slowly and gradually we can archive them as soon as we have the stats to support that the consolidation we're doing is accurate. Next slide. So let's talk about how we do that. And we start with the fact that visibility is key. Okay, we don't want to let anyone think that he loses control on his test artifacts or his process. And nothing like this. We start by taking the repository to the side and applying NLP. We will take the data and we will run the algorithms on it, and we will perform the static analysis, and we will create this optimization. This will be conducted by Qualitest. It's a symmetrical bidirectional process where that triggered on the static data, but at some point we connect it to the real repository to make sure that the efficiency lives on, and whenever a new record is being injected, it is checked automatically versus other existing records to see we're not injecting new duplication after we did the consolidation process. Next button. Everything, like I said, needs to be visible, needs to be understandable. And in the end of the process, phases 4 and 5 talks about refined automation runs, refined automation suite. In this case, those were automation test cases. And once we have that, once we worked with the delivery team to basically be comfortable with the consolidation, the reduction overnight of 30% of the tests, this became operational, and the ad hoc pack updates, basically new test cases, are automatically checked for duplication, for quality, versus our NLP, modified NLP engine that is very well tuned for this specific project. Next slide.
So that handles the consolidation and the consolidation and explains how Qualitest works. Now, when we're putting this into actual practice, what happens is that we are taking a focus now on how do we prioritize test cases. Ultimately, what we want to do is we want to find out, from the data by using this bidirectional update from Qualitest, is what happens when we look at production. What happens when we find out that code has changed, it's been checked in, branched, what have you? What happens when the application was built and when the test cases were built, and what happens when the tests failed? So what we want to do by looking at these 4 areas is we can actually predict where the most likely failures are in the application during the testing. And what that allows us to do is allows us to really change the concept of regression testing from something that says that, I'm just going to execute all the regression tests, and if they all pass, I'm pretty sure that I'm not going to have a failure. What it does is it allows us to really start focusing on testing on where we can find defects and then how we can mitigate risk. Remember, quality assurance is all about risk mitigation, not how many test cases I can execute. And so what happens is that, you after doing the test case value, after doing the automation, really what happens is that it has to stop looking at how many test cases can I execute and how many can I build versus am I building the right ones? Am I building unique and executing unique test cases? And are those test cases unique to finding defects? Are they enabled to help me find defects? And how can I get more value out of the testing that I'm doing? Originally, we did this through some sort of remediation, but all that did was it created backlogs. We try to look at what different ways to automate, but ultimately, without finding and focusing on testing or doing our failures, is the automation really that efficient? So the idea is by applying Qualitest to these areas, we can actually create a subset of test cases that, when executed through things such as Sauce Labs, does give us the ability to find defects quickly and accurately. And ultimately, what that means is that we've created a lot of optimized packs and prioritized executions. The big practices, the best practices coming from this, is really to keep consolidating our test assets, keep remediating it, keep combing through it and creating more detail, keep it manageable, but keep it effective. The second thing is to prioritize the executions. Let us target where the testing is. Let us find the defects based upon where the most code has been checked in, or even where the most people have been using your product. And then let us exercise as much testing as possible against those problem areas. We need to keep a feedback loop going on from monitoring and execution to what's happening in the software development lifecycle. Are we testing what the user's actually using? For example, are we spending most of our time exercising the help menu when they're really looking at the shopping cart? I've been in situations where this has happened. And then finally, we're using AI to get rid of waste. We want to create engineers and use engineers that are fully focused on optimizing their own time. Automation is a way of doing this, yes, but using AI as a backup, as an enabler, allows those testers to focus on areas that are either really, really tough to test or have a lot of business value. And so with that being said, what I'd like to do is, Aviram, take some questions if there's time. So is there anything that you'd like to ask?
Pradeep, thank you for your questions. Do test suites need to be in any specific format to be perform analysis? So there might be limitations, but the general statement is that no. What we do, we take your automation, we take your manual scripts, and we run them through NLP. And the way that NLP does it, it works. It takes those test cases and make them an alphanumerical vector, and it basically checks for duplication. So it represents whatever you give it to him in a way that the machine can learn and can generate insights and identify duplications. This is the long answer. The short answer is probably we can handle what you have or any format, but there are limitations which we haven't met just yet. Both manual automation, different types of automation, language is not, coding language is not a barrier. So if you apply the right kind of NLP, the answer is probably most formats are supported. Another question from Pradeep: does working with various technologies have any bearing on executing effectively? I can also take this question, Michael, if that's okay with you.
Sure.
Again, the answer is no. The system under test is not something that machine learning take into consideration. What it does take into consideration is what happened in the past and try to predict from that, together with the upcoming changes, what's going to happen in the future. So if we're talking about a real-time application or a web application, in the end of the day, what we are looking is patterns in the data. If because of a certain change in a certain part of the code introduced in a certain part of time of the year by a certain person has caused a ripple effect, machine learning will be able to notice if something like this is going to happen again and predict and prioritize accordingly. I really simplified how machine learning is working here, but the system under test by itself does not represent usually a concern. I think we have we had one question that from AJ. Can you show that working on a real world test suite? Yes, AJ, please refer to our website. You can see some really neat stuff there, and you can ask for a demo, and we can show it to you. This is the real deal. It's the game changer, and it's working. So just look at it. It's opening. It's a mind-opening thing to do, regardless to whether you will like to use it or not. Just see this in action, and really urge you guys to do that. Thank you for the questions, AJ and Pradeep. Susie, I believe we ran out of time.
Yes, that is all the time we have, and we have additional sessions starting in just a minute. Michael, Aviram, thank you so much for this presentation. Thanks to everyone who attended, who asked questions. Aviram and Michael, we do have a speakers lounge in the networking space. If you do want to hop over there, chat with anyone who has follow-up questions, please feel free. Otherwise, everyone, thank you for attending and enjoy the rest of your day.
Thank you. Thanks everyone who joined. Thank you, Susie. Bye-bye.